Example for matrix inverses. So I'm going to teach you this in the context that we're already in, which is solving systems of equations. But this thing has some more uses. So I want to introduce it kind of the easy way, and then we'll do some like kick-ass uses like cryptography and some other stuff. Cool? So first things first. Do you all buy that this is a system of equations like you've been solving?
Yeah. Yes.
Right, if you pick up, drop on, pick up, drop on, you get 2x plus 7y equals 34, and x plus 3y is 15. You all with me? Okay, cool. So one thing I could do is I can convert this to an augmented system, right? And then I could like cram it in the calculator, like rough it or something. Use all smile nod. Okay, so let me think about this in a slightly different way. I'm going to think about this in algebra land as you have some function, right, that you're doing to some x, and you're getting out some number. You didn't call functions A in algebra land, did you?
F.
Yeah, you'd maybe call them F, right?
Yeah.
So, do you all remember that sometimes there's an unfunction, right, an inverse, and you could apply the inverse function to both sides? And so you like take your whole equation and do F inverse of it. And then you'd get F inverse F done to X. Those two would like cancel. And you'd get F inverse of your number. You all buy into this? Okay. Crazy thing. Sometimes that works in matrix land. A matrix is really a function. So I think maybe for right now, maybe we could solve for x and y by taking that thing, our 2, 7, 1, 3, and undoing it, right? Undoing it somehow, and applying that to 34, 15. You guys with me on this?
Kind of.
Kind of.
What do you mean?
Okay, what do I mean by undoing it?
Yeah.
Okay, let me give you a cheater formula for right now, and then I'll show you a better way. So,
Is it because you put x and y on the other side of the equation, you're taking the inverse, or?
I had x and y on the left-hand side, right?
Okay.
X and y stayed. What I did was I took this thing and moved it to the other side and put an inverse symbol on it because I was thinking this at it.
Okay.
Right? You have some function done to x is a number, and if you want to solve for x, you do f inverse to the number.
Okay.
So I just took this thing and thought about it as a function and moved it to the other side. There's no guarantee right now that that should work at all. Why not? What do you guys remember about functions? Nothing. Bummer.
You can't have you can't have two inputs. You can't have an input that's the same. You can't have two inputs that has the same output.
Yeah, if you have two inputs that have the same output, you can't invert it.
Yes.
Do you guys remember this thing called the horizontal line test?
Yes.
That's for invertibility. How do you know that thing passes the horizontal line test?
Because
You don't.
You gotta solve it.
No idea. Right? I don't even know what the hell a horizontal line looks like here.
Okay.
Right? So I'm going to give you a way to find the inverse, and I'll show you where the horizontal line test is built into it, kind of. Okay? So if you want to invert that thing,
Yeah.
so you take your 2, 7, 1, 3 inverse. So here's the rule. You switch these two. switch the 2 on the regular diagonal. So you swap 3 and 2. And then you switch the signs on the other 2. And then you need to multiply by 1 over that thing minus that thing.
What does it matter if
Why?
it's
5 minus 8.
Close. 6
6
minus 7.
Negative 1.
Which is negative 1. So you're doing negative 1 times 3, negative 7, negative 1, 2. Why am I doing this?
Wait, where'd you get the 6 minus 7?
So I did this part, 2 times 3,
Oh,
minus
2 times.
1 times 7.
Okay, I thought you added those. I was like, that.
Multiply, minus, multiply.
Okay.
So you're making an X pattern, right? Diagonal, minus, antidiagonal. This thing is so special and so useful that it has a name. This part here is called the determinant. Yeah, really, yeah. This part on the bottom. It's called the determinant. Please note, should be an obvious problem sometimes. What's the obvious thing you can't divide by? 0. So if the determinant's 0, you're not going to be able to calculate an inverse. See that? That's going to be the horizontal line test. You no longer have to draw a picture, you can just calculate the determinant. If it's not 0, you're good to go. If it is 0, there's no inverse, do something else. You guys all good with this? Okay, so what's negative 1 times this matrix? What do you get here? Negative 3, 7, 1,
negative 2.
negative 2. Okay. So, my claim from earlier is that xy should be negative 3, 7, 1, negative 2 times 34, 15. Okay, calculator time?
I have a question.
Yeah.
Where'd you get the 6 minus 7 from?
Where did I get the 6 minus 7? I did 2 times 3
Yeah.
minus 1 times 7.
Oh, okay.
I'll write this formula down with letters in it so you can get the kind of general thing at some point here.
Okay.
So, how do you do this multiplication? Pick up, twist, drop on, right? So you're going to get negative 3 times 34 plus 7 times 15 and 34 minus 2 times 15. You guys with me? Okay, so the bottom one at least is 4. Somebody want a calculator me at the top?
Negative 1 or 2.
It's 3.
Baller. X is 3, Y is 4. Check done. You guys cool with that?
Wait.
What?
How'd you get to 3, negative 7, negative 1, 2 again? Real quick, sorry. Yeah, right.
This dude?
Yeah.
Okay, so that's flip, flip.
Flip, flip.
So switch these two,
Okay.
change the signs on those two.
Wow. Okay.
Because that's the rule for it.
That's a rule. Okay. When you're doing inverse.
Yeah. Another way you can get the inverse is you can make the calculator figure it out for you. Okay, so I'm going to show you how to use the calculator. I'm going to show you this rule, and then I'm going to show you yet another method. So you're going to have 3 methods for calculating inverses, and I don't care which one you use.
Wait.
So what would the answer be? X, Y is equal.
This right now is just an
X is
example,
equal-
I'll show you the methods.
Would it be X is equal to 3 and Y is equal to 4?
It is exactly x is 3 and y is 4.
Okay.
And that's the solution you get, right? So my answer for this problem up top looks like x is 3, y is 4. And what's the context for that? Like what's the interpretation of that?
Like,
Or y equals 4, x equals 2.
So remember this was 2 x's plus 7 y's is 34. And x plus 3y is 15, right?
wait, do you want us to solve it?
You guys all see that? What's the context? What are these? Like, what is 2x plus 7y equals 34 in space?
Line.
Those are the intercepts.
That's a line, right? So this is a line, that's a line,
Oh my god, they hit it.
that's where the two lines hit.
Oh.
Cool. And I used that, or I used a matrix inverse to calculate this. It's all kinda okay? Okay, let's get methods for calculating this.